水滴坏掉。
都已经28学分了，
累，超人，
我操，
超人，还有活动吗？还有活动吗？
哦，今天是7节，这辈子还会再。到明天。外面爆外面爆啊！天啊！确实，天啊！我知道到明天了，还不好意思，他12月还有台风，对啊，超级1开2，干什么？怎么可以这么爆的呀？什么钱啊？然后他爆后有没有考的这个都不知道的，我也是，我也爆2，爆2，不要啦。认手啊！因为你知道为什么？因为我妈说，如果你2万没过的话，我不会帮3次的钱。所以我就说，那我去考2好了。他有钱都不是问题，我还没去参考，还没。啊，我还要过来哦！你就是在台北干嘛呀？我要你有水？但你进球要上传到这学期把修完。在日本都晚饭了。
我请了开自己没关系啊。
感觉大家都是在一边喝一边聊。所以没出去啊，我就没有发现这样。哦，可以这样，
对呀。
It's like the local, you can start. Here until 10 and 20.
There's an active professional.
I like one bedroom.
Hello. Okay, can you hear us? Can you hear me? Do you hear my voice? Hello, hello, hello. Oh, you don't hear me? Okay. You don't hear me.
Ooh, how about this?
Yes, sir.
Okay, great, thanks. So hold on tight. It's 3 minutes before the lecture. Yeah. So who wants to add the course? Okay, can you come here? Oh, 机械系。
对。
OK，重修，重修，重修，重修。OK。那你们要，因为有2个班，要加哪个班？不是有2个班，一个是 GD，一个是 IT。你们要加。
So if you want like a
No.
签好了。 签好的人，签好的来签。Okay, so in today's lecture, we don't have to do any teaching, just to introduce the course. Okay. So later on, please make sure you have joined the new Facebook group. So we will use two different methods to send you the messages about the course. One is the Facebook, the other one is Moodle. So I'm never on Moodle. My TA sometimes go to Moodle. If you ask us any questions from Moodle, our reply will be super slow, or we may never reply. So please just go to Facebook. Okay, that's easier for us. Okay. So about the lecture, it's a merging course between IATP and GTAC. Okay. So this lecture, we have some students also from mechanical engineering. This is an English course. Sometimes when Taiwanese cannot understand easily, I may speak 1 or 2 sentences in Chinese. I will try to be professional and use English all the time. But if you ask me questions, you have difficulty speaking up with Chinese, with English, you can use Chinese. I will try to answer in English. So there's a TA, she's Ella, she's my graduate student. So she will be the TA for the course. Her contact information is right here, okay? And this spreadsheet will be sent to you later on from Facebook. So you don't need to write down anything. In this semester, I am very busy, so some of the courses is going to conflict with my travel plans. So I have a supporting lecturer, Professor Brijesh Patel. So he is my postdoc. He's also a professor in India. So he will sometimes help me to give lectures, okay? He is online. Dr. Patel is online right here.
Yes.
So you guys know him? Oh, okay, good. Yeah. So he sometimes show up. Yeah. Okay, great. Let me come back to the schedule. So we use a textbook. It's called the Shigley's Mechanical Engineering Design in the SI unit. The book is very expensive, so you don't need to buy it. But if you can buy one, it's actually highly recommended for your future. This book has 2 different parts. In the first half, it's about mechanics of materials, and also some knowledge about manufacturing, and also the concept of fracture mechanics. In the past, when you learn mechanics of materials, they don't teach you about what's gonna happen after the material fails, right? You only know when the force is greater than a certain limit, the material fail. In this course, we also don't tell you what's gonna happen after fail, but we teach you something different. We teach you something new. We teach you how to design in order to prevent failing. Okay, so in the past, it doesn't teach you the concept of design. In the mechanics of material course, you only learn how to calculate the stress, the strain, the formation inside the material. Pretty much that's all about the course. And in this lecture, we are becoming mechanical component designers. We need to know what are the important parameters to be decided by you. One thing is, should I use a stronger material or weaker? So obviously, if you use a stronger material, it should be good, right? But sometimes the material is too heavy. When it's strong, it's heavy. So you sometimes want to use a lighter material. But when you use lighter material, the strength becomes weaker. So there's a trade-off. You cannot, there's no perfect world. Your decision cannot be perfect. Okay? So we need to learn certain knowledge from the course, and then we need to know what we can do for mechanical design. And this book includes the knowledge that is required for mechanics of materials, and also the concept of failure, and also some design equations, so that you know when you make a decision, that equation help you to figure out what's your limit. Okay? And in the second half, it has several chapters about different kinds of mechanical components, such as the common ones, springs, gears, pulley, and many other kinds of components. So all these components are having different shapes. Because of the shapes, and also they are utilized for different functions. The way we apply the loads on the components is very different. So the stress analysis for each component is very different. So sometimes it's difficult to learn this course because when we are moving on to the second half, when we introduce different kinds of components, each chapter are so different from other chapter because they are introduced for different kinds of components. Okay, they use different equations, different load conditions, and so on. So for the second half, I will just introduce you some common components. I will not ask you to do any homework about it. I will not do any exam about it. So I think the most important thing is you need to learn about the first half, and you need to have the understand the knowledge for design. And for the second half, I share the knowledge with you, and I hope in the future that's useful for you. And in the second half, we will be doing some projects. Okay, so while you are doing the projects, different team may be focusing on the design of different components. So you may be more interested in gear design, or the other team is more interested in making a decision of the bearings and so on. So different team will show different progress and performance. So I hope the introduction in the second half can help you in your design. Now, here's the schedule for the course. It's quite messy, quite complex. So let me tell you what's happening. This is the day. Nothing's gonna happen. I just tell you what this semester is about. And in this particular column, this is what I need to do for each day, for those days. I am participating 1, 2, 3, 4, 5 conferences, giving a talk in Zhongshan University, and being a judge in a competition. So I don't know why all these events unfortunately conflicts with this course. That's why I invite Professor Patel to help me. We will be jointly teaching the course. Okay, so since this is the first week, so usually no class in the first week. So tomorrow, there's no class, only 1 hour. Even you guys count, 1 hour is very short. So I decide we just say no course tomorrow, no class tomorrow. So starting from next week, we will be having a full week of lectures about mechanics of materials. You have learned those already in the previous courses of mechanics of materials. You have learned them, but you may already forget about them. That's fine. I recommend you to go back to your check your own notes, find out where is your old textbook, and kind of review it. Okay, because we are going to have one exam The exact problem usually looks like this in this course. It's like a shaft problem. It's not beam problem, shaft problem. Shaft. So basically a cylindrical object. Why are we so caring about a shaft? Because if you think about a machine, usually we need to have some components that's moving. And the most common way to drive those components is to use a motor, right? And the motor basically spins, rotates. And what do you usually rotate? A shaft, okay? And you can put all kinds of components on top of a shaft, right? You can have a gear, right? A gear. You can have like a pulley, pulley and belt, like this. This is pulley and belt. And you can have, in engineering drawing, sometimes they draw something like this, right? The bearing, right? Some of the Taiwanese are not familiar with the English words, 齿轮, 轴承, 皮带轮, and 皮带, right? Gear, bearing, pulley, belt. Those are mechanical components. They are installed on a shaft, a shaft. So there are all kinds of loads applied on top of the shaft. The shaft basically deforms. There are stress on top. We need to know if the shaft can carry the load. We don't want the shaft to deform too much. You may bend the shaft. You don't want to ride your motorcycle and one day one of the shaft bends, then your wheel cannot spin anymore, right? So in our exam, the first problem is about a shaft, okay? So usually I have a shaft and maybe there's some bearing on the side, and maybe there's like a gear and some force being applied here. You may have reaction forces, so you can study the shear diagram, right? Shear diagram and moments. Do you still remember these? Right? We are doing something like that. Okay? So you need to go back and figure out these. And then we need to figure out, right, at some point, at the location where you install the gear, you have the largest moment, and that's where you have the largest stress, the largest. Okay, when you have the largest stress, that's where the material could be failing. So, and since the stress can be applied at different locations, so we may need Mohr circle. Do you remember Mohr circle? We need Mohr circle to figure out the principal stresses, because they are aligned on different directions. It's not a 1D problem anymore. It's a 2D or 3D problem, right? So you need to find out, okay, the largest stress. And later on, I will teach you about failure and fatigue. They need the information of the largest stress inside the material. Any design equation is depending on the knowledge of the maximum stress. That's why in the first part, we need to remind ourselves how to analyze the maximum stress inside a component under some kind of loading condition. Okay? So, first week I will give you some review. And because the lecture time is very short. We have a short-term semester. So I also have some supporting material for you if you feel like the lecturing is not enough. We have a YouTube channel which keeps my previous teaching videos. So you can go there and watch those videos. My lab is called the Design Automation Lab. And we figure out optimize. If you search DL optimization, it's no, it doesn't show up. Let me find out where. This one. So I need to. Okay, this is the account. So in the playlist, there will be several semesters of design of mechanical components. So you can go and watch as many as you want. You don't need to give us like. I'm not earning any money from this, okay, so no worries. And also, we have my lab has a web page. It's called the NTUST ME Mechanical Engineering DAL Design Automation Lab. So if you go there, this is my my lab web page. There's a link called online lecturing. If you go there, I actually put all the teaching material online. So this is also a good way to find out some video. It tells you, okay, like I always review the solid mechanics, and I already taught this course several semesters. In the beginning, I taught this in Chinese, and then later on, I taught this in English. So if you're Taiwanese, you would like to learn this in Chinese, that's okay. I have Chinese version. So I have videos, PowerPoint files, and so on. There's so many of them. And sometimes I do a good job in one semester, the other maybe not as good in the other semester. So if you don't like it, just watch another one. Or you can just ask ChatGPT, hey, can you recommend a good online video on YouTube that can quickly remind me about such knowledge? Definitely, you can find a better video than mine. Okay? My video is not very, very good. But if you watch my teaching video, at least you know what I want to cover. And you kind of get a sense about what the exam is about. Okay? And you can also move forward and take a look at the previous exam problems. You can kind of practice by yourself. And then I usually don't, I never repeat the problem, but I usually stick with some same kind of problem. So usually it's just the change of values or change of the conditions. But the problem type is the same. So you can already go online and practice. Okay? So Ella, please share. I will copy this. How about here? I will tell you some of the knowledge some of the information I shared today. So I will also share with you about our YouTube channel. Okay. Yeah. Let's get back to the schedule. So this time I will be asking you to do self-study more. So I won't cover too much on the lecture. Okay, so I will let you know, okay, this is where we need to learn, and you can go back home and study. But I will, before the exam, I will use one lecture to do some exercise, real math solving exercise in the class. Okay, so we will be doing a particular problem right in the classroom, and you guys will start to try to solve it with the lecturer for the day. And when we have physical exercise week, physical exercise lecture, by the end of the lecture, you need to hand in your practice. You can copy what we did on the screen, on the board. You can copy your friend. You can do it by yourself. It's just an exercise. But it's a good way for you to at least try to do something in the classroom. So you don't rely on AI too much. Okay? So we have one lecture of exercise before every exam. We have 3 different exams. Okay. Here, what does the color represent? Blue color means I will be here. Okay. Yellow color means I won't be here. I may be online, or I may not be online. The yellow one, Dr. Patel, is here. But I know there's 1 week we're both not in Taiwan, so we will both be online. I think that's September 16. We are both online. I think that's the week. And anyway, so we may be online both. So Ella will be here. Anyway, red color represents the exam. Okay, so for the exam, it's always in the first 2 is just 1 hour, but the third one is 2 hours. But I try not to give you too many problems. In the past, students had difficulty finishing the problem, so I will try to make it simpler. Okay? And second part of the lecture is about failure, but with static loads. And the third part is about fatigue, but it's a dynamic loads. So basically loads that changes with time. Right here at October 14th, there's a special lecture. We would like to invite ANSYS, a company personnel to come here and teach ANSYS. Because later on in the second half of the course, you will be doing some projects. You may rely on ANSYS to do stress analysis. Okay? So there will be one course about ANSYS. And then, as you can see, starting from November 5th, I will start to introduce different components. So I said component 1, 2, 3, 4, 5, 6. I have 6 different times of opportunity to share some knowledge about mechanical components. Okay? So it will depend on what I would like to introduce for the day. And then you can just listen to what I share. Okay? And you can, of course, ask questions. And please pay attention on November 11th. That will be the time you guys give a proposal about the project. And before that, on October 15th, if Dr. Patel is available, he will introduce some examples. So what are the examples? Those examples are some mechanical designs in our lab. We have several different designs, mostly in robotics. And those will be the topics for your project. So we have different robots. They all need better mechanical design. So we will show you the real robot that we built. You can physically see it and touch it in our lab. But for the lecture, Dr. Patel will just present it as a PowerPoint. But later on, you can go to our lab and touch it. And we will tell you, we think this particular mobile robot needs a better motor because the component is getting heavier, the motor is not strong enough, it's not powerful enough to drive the whole mobile robot anymore. So we need mechanical design. So if you are selected or at the end becoming a group member who will be making design decisions for that particular robot, that motor selection would be one of the topics you can work on. And also, maybe another robot, it's too heavy, we want to reduce the weight. It's already too strong, too bulky. So you can propose to modify some of the components. Maybe there's a column, a metal column, way too strong, way too heavy. You can propose to design the column in a certain shape, analyze it by the software ANSYS, proving that even after the reduction of the material, it's still strong enough. But the result of your analysis shows that it's still strong enough and giving you less weight, so it's more energy effective, something like that. Okay, so Dr. Patel will be introducing the mechanical design examples from our lab on October 15th. So that will be the time you know about the topics. So there could be, let me see how many students. We have 27 students, so usually we don't want a big group. If we have 5, then 4 to 5 students in the group. So maybe 5 or 6 groups, okay? So we will be doing some grouping, and each group focus on one particular problem. So I will be finding 5 or 6 mechanical design examples from our lab. So on October 15th, you will know about them. And on November 11th, you will be making a proposal presentation about how you want to improve it. Okay, improve the design. And on the November 25th, you will be making another presentation about the progress. So just basically report your progress. And at the end of the semester, December 16th, you will make a final presentation about what you have done. This will be mostly simulation-based or analysis-based. You don't truly build one, okay? Because budget concern. And we also worry if you are not making the right decision, then you may damage some of the stuff. So this project is just for you to practice. And of course, if you really give us a very nice recommendation, we may truly modify our components based on your design in the future. Right? And right here, we have November 26th, Dr. Patel is going to share some of the design experience in autonomous mobile robot. So basically, we have been working on different kinds of autonomous mobile robot in our lab. So he will be sharing some of them. And one lecture before the final presentation is gonna share something about industrial robots. We have done so many applications and projects related to industry robots. So you basically give a presentation. Okay, so every time there's a lecture right here, you will need to do this roll call for attendance, like what you did for the QR code. And every time you do it, you get half of the point. So in total, for the lecture, you can earn 10 points by just being in the class. Okay, and then as I mentioned, we have 3 times of physical exercises before the exam, and then you will be doing some problem solving and handing that particular solution sheet, and that sheet gives you 3 points. This is like a on-site homework. So you get 9 points out of the on-site exercise. And for the exam, it's 15 points per exam. So in total, it's 45. It counts a lot. So please, you can already start to prepare for the exam. And for the project, you have a proposal, you have a progress report, and the final presentation. In total, it's 36 points. Okay, so in total, the course is 100 points. That's the basically what this lecture is about. Now, please let me know if you have questions. This is the time for you to ask me questions or speak up or whatever. Okay. Yeah, go ahead.
The Facebook link or the Facebook group, where can we find it? Or what is Facebook?
It's right here, the one on the right. Yeah. So please go ahead and join the group on the right QR code. You can also do the roll call on the left, but the roll call for today doesn't count. Yeah. Doesn't give you points. Yeah, because first week some student may just add a course or drop a course. But if you want to show me that you're here, you can do the roll call on the left. Any questions or expectations? I have one question about for you guys. You can let me know what you want to do. How would you like to do the grouping? Do you want to group by yourself or you want to do random? Let me tell you the pros and cons. Nowadays, many lecturers do this kind of a grouping and group project in the second half of the course. And if you already know someone, it's easy for you to find your group member. But not everyone knows everyone in the class. And sometimes due to the limited student count in each group, so sometimes there's 1 or 2 students left out. So grouping by your own will sometimes will be not so good for some students. And so we can do random grouping. But the disadvantage of random grouping is that you will be grouping with someone you don't know. And I never see one class with all the groups being grouped perfectly. There's never a class that has all group being grouped perfectly. Because there's always one group, one of member doesn't like the other one, or there are always issues. Some member doesn't show up. There's a member who is like a one man group, one man leader who does everything. He wants a higher score. He complains about his teammate doesn't. How come he gets the same score and stuff, right? You know about the stuff. Yeah, I will try to give you fair scores, but it's never fair. There will be someone who will be working way harder than others, but not getting 200 points. The max I can give you is 99 points, right? And there will be someone who did nothing, but luckily his partner is super nice and did all the work, and he got 80. I would never recognize it unless you let me know and complains about it. If you and when there's complaints about this, okay, I will try to make adjustment about the score, but you may not like it because the adjustment will be very minor. Okay, so let's do a voting. How about that? Let's do a voting about grouping on your own and random grouping. How about that? Okay. So if you like to group by yourself, can you raise your hand? Okay. I guess about. Okay. How about random? Who wants to do random? Okay. So you guys will be grouping on your own. I guess now is a good time for you to find your group. Okay. Because you can already know who's your member. If you already know who's your member, please come up here and how do we do it? So we have 27 students. I think the most, I'm looking for at most 6 groups. So you can do 4 or 5 students. 4 or 5. If you only have like 2 people, that's fine. Just tell me, okay, I have 2. There will be someone who doesn't know anyone. Then you guys will be put together. Okay. So if you already know who you are grouping, you can come here, and I will figure out a way to put you guys together. Any other groups? Yeah, come here. Okay, any others? Who doesn't have a group? Yeah, maybe you can join. Yeah, join. So, what's your name? What's your name?
It's Muhammad.
Yeah. Okay, good. Okay. Okay, you show me? Okay, good. Feng Sheng and Xin Shi, right? Okay, good.刚好这边。So I guess you guys are the 6 people. 5. Okay. Okay, so let me know who are the guys. Okay. Okay. Yeah. So is he going to? Okay, so it's fine. If there's typo, that's fine. We can correct it later. So please let him or her let him know he needs to come and get the code. Yes. So you get the fifth. So there will be Ricky and Tim. How do we do with Ricky and Tim? Yeah, we can do 6. That's fine. So, one more? Okay. So, how about Ricky adding to that? Can you tell them? Ricky joining you guys, okay? Group one. Okay, good. So basically, 2 GDEP groups, 2 IATP groups, and 1 ME group. So we have 5 groups. That's good. Okay, so here's the current grouping. Okay, we have 5 or 6 students. If later on you want to do some swapping of the students, that's fine. I just have an initial grouping. Okay. Any other questions you may have for today? Everyone happy about?
What's the project about?
Say again?
What's the project about?
You want to know about the project?
I didn't even hear about it before. Never.
Okay. I can. Let me see. So there's a Center for Intelligent Robotics. So maybe you know or maybe you don't know, I'm the director of the center. And we have several members in our center, including our president. So if you click on my name, this is about obstacle avoidance. And this is about also obstacle avoidance. This is about autonomous mobile robot. So as I mentioned, you may have a robot that moves. This is one of them. Okay, so like in this particular design, one of my graduate student, she's a master student, she designed the base purely on her own idea. And it's not perfect. So because the wheel is very wide, so the metal plate at the middle kind of need to carry the load from the top. so the base kind of bends a little bit. So my second student who take over the design put some like a rolling wheel at the center part underneath the metal plate as a support. But that caused a new issue. So there's mechanical design is like finding the issue and solving the issue, but causing a newer issue. Yeah. But anyway, so it will be fun, and later on you can physically see and touch it. So guess how heavy this guy is. Let's guess. Feel free to guess. Say again. 2 tons is too many, too much.
150.
150? What's the unit? 150 kilogram. Way too low. You guys want to guess? Guess the weight.
600 kilograms?
Not enough. Want to join? Want to guess? Higher than 600 kilogram.
1 ton?
About right, 1.5. So guess how much weight the robot can lift. So-called the payload. So if the robot grabs someone's head, can the robot grab me or my student? So yeah, what's the payload? 50.
50.
15?
Yeah.
Way higher.
Way higher.
Way higher. 60?
600 kilograms.
No, too much. Way too much. It's impossible. Yeah, continue.
80. 80 kilograms.
Close, but lower. Slightly lower. Slightly lower. Almost there. 70. The payload for the robot is 70. So if the robot grabs my student's head, the robot can lift my student. So if the robot grabs my head, it doesn't, because I'm over 90. So it's a huge robot in our campus. You will see it later on. My student can share some of the mechanical engineering drawings for some of the components, and then if you pick this one, or this topic is being randomly assigned to your group, we haven't decided yet, but if you are working on this, you will see how it was designed, and you can make adjustments. And then, no matter what you modify in the CAD files, you will use the software to analyze the stress. So that would be the fun part. You make something, you change something, it turns out it's getting worse. Okay, then change it back, do something else, something like that. So that would be the fun part. Yeah?
What software are we using in this class?
It's called ANSYS. ANSYS. This is in Chinese, but you can always go to the English page. Yeah.
For the design also, or just for the analysis?
No, this is for stress analysis.
Just for the analysis.
If for CAD design, you can use SolidWorks, Pro-E, I don't know any other. Rhino.
Creo Pro.
Creo, yeah.
NX.
Yeah, I don't use that, but you feel free to do it. And there's another software if you are willing to learn. There's something called HyperWorks. It's from Altair, the company Altair. This software, we have it. It does something. It's called topology optimization. So what is topology optimization? Like this concept. Actually, Ansys does it as well, but HyperWorks does it better. So if you have an initial design, you think it's too heavy, you want to reduce the weight, the software figure out where are the locations that carry the stress more. So the parts that carries the load needs to be there. But there will be some other parts that actually doesn't carry loads too much. You can cut away those materials. So it kind of removes some of the material from the original one and starting to make drills and holes. And at the end, you have like a truss-like structure. It's definitely lighter in weight, but may not be too weak on strength. So that's a concept of topology optimization. But the disadvantage of this kind of structure is that it's harder for manufacturing. Right? The shape is weird. Then you need to figure out how to manufacture it. Okay, so we have software like that. You can, if you are interested in topology optimization, you can use the software to reduce some weight, and then let us know how it turns out at the end. Okay. Okay, great. It's nice to have this kind of communication, and so that I thank you for letting me know what your question is, and I can give you some of the new ideas in my mind. Okay? Oh, by the way, I forgot to tell you, right here is about my different ways of contact. You can call me, you can send me a personal message, Facebook, Line, email, that's fine. What is this about? In the lecture, I may be writing notes, maybe on the board, maybe on iPad, and obviously I will be writing in English. And sometimes my handwriting getting more and more sloppy as I speed up the lecturing. So sometimes you don't realize what I'm writing about. So I try to write down the capitalized ABCD and the small case capital ABCD and show you how it may look like in my notes. The most difficult one is small case R. The small case R sometimes look like a weird stuff, like a small thing. So yeah, if you need to realize this, you can take a picture of this. Sometimes you just have no idea what the professor is writing about. Okay, compare it to this. Right. Okay, that's it. That's it for the day. See you next week.